Section 5.4 continued. This is the fourth and hopefully the final video in this particular section. You want to go all the way down to where it talks about bearing. Now, I'm going to talk about two different methods of dealing with bearing. The first method is when just a single angle is given. And we are going to understand that bearing is measured in a clockwise direction from north. So I have four different examples here. A bearing of 32 degrees, 164 degrees, 229, and 304 degrees. And so you can see by the pictures, starting at north, going clockwise 32 degrees. Here, starting at north, clockwise 164. Starting at north, going clockwise 229. And clockwise, starting at north, going 304. And if you think about it too, even like this, if I had stopped here, that would be 90 degrees. If I'd stopped here, that would be 180 degrees. If I had stopped here, this would be 270 degrees. So this is going to be past 270 degrees. All right, so what I've got here, this first part is actually not a story problem. I took it from a story problem, but basically the only reason that I have it there is to show you how to draw a picture when you're given this particular set of information. All right, so you can maybe pause the video and look through that. I would strongly recommend that you read the question carefully and figure out how they drew the picture that they drew. We're going to go straight to example number 5, though. And again, in this particular video, what's going to take the longest is the drawing of the pictures. The math doesn't take quite so long. It's the drawing of the pictures that takes a lot longer. All right, so in example number 5, we have radar stations A and B are on an east-west line, 8.6 kilometers apart. So the first thing I'm going to draw is my east-west line. It's 8.6 kilometers between my two stations A and B. Station A sees a plane at some point C. Now, at what bearing is that? It says that it's at bearing 53 degrees. So what we're going to do is the first thing we have to do is establish the north line. And from the north line, we're going to go 53 degrees clockwise. All right, so 53 degrees clockwise from north. The station A, the radar station A, detected that airplane. All right, let's keep reading. Station B detects the same plane at the same time, only it detects it at a bearing of 323 degrees. So once again, let's go ahead. I'm going to do these in red so that it's different. Let's show the north line. And from the north, I need to go 323 degrees clockwise. Well, let's see. If I were to stop here, that would only be 90 degrees. If I were to keep going, that would only be 180 degrees. If I were to keep going, that would be 270 degrees. I need to go past 270. So I'm going to go a little more past 270. And this is going to be 323 degrees clockwise. I'm asked, and wherever these two lines of sight intersect each other, this is going to be where my airplane is. The intersection is at my airplane. All right, so I'm asked, the very last sentence, find the distance from B to C. And since that's opposite angle A, we're going to call that side A. Now, before I can get an equation, I need angles that are on the inside of my triangle. Right now, all of the angles that I have are on the outside of my triangle. And so the first thing that I want you to focus on is this angle right here. Remember that the dotted line is the north line, and the solid horizontal line is my east-west line. Hopefully you realize that your north line and your east line meet at a right angle. And so if these meet at a right angle, then you can easily tell that these two angles that I've drawn are complements of each other. And so if I do 90 minus 53 degrees, I'm going to get the angle on the inside of 37 degrees. Now let's go over to the other side. So once again, yes, my two angles are complements of each other. However, I've got a 323 degree angle. Now, if you did 360 minus 323, that would give you this angle. And then you could use its complement to get this angle. But how about this? Let's do something a little bit different. Remember that if I had gone all the way to this point, that would have been 270 degrees. So if you did 323 minus 270, that would just give you this piece. So that's two different ways of finding the angle, and I'm going to get 53 degrees for this. All right, so the last thing that I would like to do is I need to find what is the angle at C. What's the angle at C? So if you add up your two angles, the 37 plus the 53, you're going to get 90, which means that this is actually just a right triangle. And since it's a right triangle, then we can solve according to the methods that we know to use for right triangles. So let's take a look. Pick an angle to focus on. And I'm going to be honest with you, I forget which angle I focused on. So I chose the 37 degree angle to focus on. If you focus on the 37 angle A, and you want to find side A, and you know this guy, well, let's think about what this is. You know that side A is the opposite, but this is the hypotenuse because it's opposite my right angle. So what uses opposites and hypotenuse? That's going to be the sine. So we'll set up our equation. Sine of 37 is equal to the opposite over the hypotenuse, A over 8.6. We'll multiply on both sides by 8.6. Throw that into the calculator. We'll get A equals 5.1756. Please notice, though, that all of my sig digs are in 2 digits. So we're going to have 5.2 kilometers for side A. All right, then the next thing that we're going to look at is method 2 for bearing. And this time I'm actually going to have 2 different directions, not just a single number like I did up here. All right, so let's take a look. We're going to start with your north-south line, and then you're going to use an acute angle, only an acute angle, and you're going to move east or west from there. So again, always, always, always do your north and south first. Always do that first. And then it's going to have an acute angle after that, and then you'll have your east and west line after that. All right, so take a look at these 4 examples. I read this northeast 42 degrees. And so if this is a north 42 degrees east, either one is okay. North 42 degrees east, establish your north-south line first. Okay, so I'm dealing with my north line first. And from my north, I'm going to go east of that 42 degrees. We know that east is to the right of north. If I'm looking at this one, it starts with south. So you go with your south first, and we're going to go east of that, which is to the right of that. This one is southwest. So once again, get your south first, and then go west of that. And last but not least, we've got north first. Once you have your north, go west of that. All right, so again, just like I did on the last one, I've given an example of simply how to draw the picture. I would take some time, either after the video or pause this video, and just figure out how they drew the picture that is there according to what they're given. But I'm going to walk you through one that is similar to that. All right, you have a ship. It leaves a port. My ship sails on a bearing of southwest. Let's stop right there. All right, so the first thing that I'm going to do is I'm going to choose where to put my port. So I'm going to call my port here A. And since I'm going to go southwest, the first thing that I'm going to do is establish my south line. Okay, so there's my south line. And from my south line, I want to go west of that. Well, west is to the left. And I'm going to draw an angle. Okay, and that angle is 34 degrees. So there's my southwest. The solid line is the path that the ship took. It says I'm going to go for 2.5 hours, but I'll deal with that in a little bit. Then my ship is going to turn and sail on a bearing of northwest. So once again, decide what's north. There's my north. And I'm going to go west of that. Now, before I do this, can you look at the picture that I have here? Do you notice that I have 2 parallel lines with a transversal? If that's the case, then this 34 degrees is going to be the exact same measurement here. 34 degrees is going to be in that angle. We'll use that in a minute, but I just wanted to point it out while I'm there. All right, so let's go back. I'm trying to go northwest. I've already drawn my north line. And so what I want to do is I want to go west of that. Well, west is in this direction. And so I'm going to go west. All right, so now let's put in a few more values. We already know, oh, by the way, this was northwest 56 degrees. So let's put that in before I forget. And because of what I just said a moment ago, you know that this is 34 degrees. Now, let's keep reading the question. If the ship's rate of speed is 18 knots, which is nautical miles per hour, find the distance that the ship is from the port. So think about what happened. My ship took this path right here, and then it turned and took this path. So at this moment, my ship is going to be here at point B. I want to know how far is it from the port. So I'm going to go ahead and connect those dots. How far is my ship from the port? You'll notice that 56 plus 34 is 90 degrees. So this is a right angle. So we'll call it angle C, which also means that I want to know what side C is. This over here is my side B, and this over here is my side A. Now let's go back and read about those distances and those times. So it went 18 knots for 2.5 hours. For 2.5 hours. This was the first path it took. 2.5 hours at 18 miles per hour. So all we're going to do here is just simply 2.5 times 18. This was the first part of the path. And so I'll find that that is equal to 45 miles. So side B is going to be 45 nautical miles. Well, when it turned, it sailed at 18 knots for 3 hours. So we'll do the same math. And we'll find that the ship went 54 miles. So side A is 54 miles, nautical miles. I'm trying to find side C. Well, I have 2 legs of my triangle. I want my hypotenuse, so I say let's just set up the Pythagorean theorem. We'll take the square root of both sides, and when we do that, we'll have 70.2922. Notice that everything I have is in 2 sig digs, so we'll round that to 70 nautical miles.